data structures, again, is what our focus will be on today, collections and sequences. So what are going to objectives? We'll talk about complex data structures. Actually, what I meant to say here is complex data types. Complex data types, we talked about data types on the first day, but now data types become more complex. We need to put them in data structures. So data structures, definitely, I don't want to say complex data structures. And the two main types, the sequences, which you can see include arrays, lists, and tuples. And we have collections, which are sets and dictionaries. We'll talk about how to create and use them, also manipulate them, and some of the operations, like the functions that each one of these collections, or should I say data structures, do have. So at the end of the day, we will be able to learn about sequences like lists and tuples. We'll also learn about collections like sets and dictionaries. Now, let's go back again to the very beginning. Oops, I think I lost my video here. All right, so let's go back to the very beginning when we started creating variables, right? We remember variables are a space in memory that we, just like, you go and open a bank account and they give you a particular location for your bank, or if you go and open a vault account, depending on what you want to save in the vault, if it's jewelry or if it's documents or if it's bags of gold or if it's cash, they'll know what amount of space to give you. Last class, we were looking at players that were playing dice. We had to create player 1, player 2, player 3. Each time, that means you're saving space in memory. So it becomes cumbersome when we have multiple, many variables. So sequences help us to be able to group all these variables and put them into one container, into one structure, what is known as a sequence or a data structure. So rather than having each one of them and keeping track of each one of them all the time, we just have a structure. Let's say instead of having 11 players with 11 different variables, we just have one team. That team has 11 spots for those 11 players, and we just keep track of that one team, and we keep changing the numbers of the players and so on. Does that make sense? So again, sequences, there are 3 major types. We'll talk about them shortly, but you have arrays. Arrays are not built in. Remember how we talked about last class, how we have functions that can be built in or user defined? So arrays are not built in into Python. So if something is not built in, we usually have to import it. So if we have to use arrays, we have to import it. But lists and tuples are built in to our Python. So we'll talk about all of them shortly. Let's jump in quickly. There you go. So what is a sequence? A sequence then is, like I pointed out, a set of variables grouped together. Okay. The variables usually have a position, which is known as an index. It's zero-based, meaning that the index always begins from 0. As you can see here, the index is starting from 0. Here we have 8 different values that we want to keep track of. These values are known as elements or items. So the element on index 2 is 30. The item at index 4 is 50. All of these belong to one array or one tuple, which we'll talk about shortly. The difference between the two, though, is arrays, like I said, they are not built in, so we need to import them. So if you want to import an array, it's always good to consider using NumPy. NumPy is a library. We talked about libraries. The reason we use NumPy is because NumPy is a library that has a lot of functionality in it. What we can do is pull that library and just pick up to get a particular function or a particular class out of it, or a particular module. In this case, the module will be arrays. Okay. So arrays, again, question, Aaron.
So if you could help simplify what an array is it just a 2-dimension? At least a 2-dimension?
Arrays could be 2 or 3 dimensions. So think about, say, in a soccer team, let's say in a soccer training room, right? All the players have their separate lockers, or in a police station or in a school. All the students have their lockers. Each student has a locker. That space is fixed, and you go in there and put your items in there. The item that you put in there is the element, but that position is the locker. So it's fixed in, you could have multiple dimensions, but for us to start in a simple sense, it will be just 1 dimension. Okay. But
okay. When you say, I just want to kind of have that a bit clearer in my mind.
Yes.
So again, I'm just trying to compare that with a list, right?
Yes.
I see that a list is you have multiple items, but in just like one direction, one dimension.
Very good.
Is that making sense? I just want to try to clarify that for myself.
Yes, to clarify it, I'll help you again to clarify it even better, because after this, we'll talk about a list. But for now, I want us to start with the arrays, because the arrays are the basic ones. And once we understand the array, when we get to the list, I will definitely point out the differences between the arrays and the list, including the tuples and other different data structures as well, right? But for the arrays, let's just think about it as maybe a parking structure. You have 10 cars that have to park in there. The first car comes in and parks in, it's a Mercedes. The second car is a Ford. The third car is a Benz, or the fourth car is a Jaguar, and so on and so forth. So all those cars are parked in a fixed location. If we want to say which car is parked in spot number 3, we give it a particular name, or we get the value out of it. So those are fixed, okay? But for arrays, it's important to know that arrays have to take a uniform or homogeneous data type. So all your arrays have to be either integer or double or string. You cannot mix and match them. Okay.
So that slot that belongs to a Mercedes, you said is fixed.
Yes.
Is it possible to assign that slot to something else, or it's just going to be for the Mercedes?
Very good point. So there are a few things that we're going to talk about also to clarify that. When it comes to data structures, the main thing we want to talk about is the type of the data. Is it homogeneous or heterogeneous? Is it going to be the same all along? So if it's going to be a car, you have to be a car. You can't come in and park an airplane in there, or come and park a boat, right? So that's the data type. Another thing we have to talk about is it mutable? Can we change it or can we not change it? So when we talk about all of those different data structures, then I'll be able to clarify again which ones are which, so that it paints a clear picture, okay? But for now, since we're talking about just arrays, it's challenging for me to compare it with the others without mentioning it yet.
Okay, I'll hold my question. So
okay, good. So yes, so those are the two things I talked about the type of data. Is it uniform, as we see here with arrays, or with tuples? Tuples have varying data types, meaning you can have 10, you can have boy, you can have 30, you can have 7.5, you can mix and match whichever, whether it's an integer or a double, and so on and so forth. Okay, but with tuples also, they are built in and they come with Python when you install it. So if it comes with Python, that means you don't have to import it, so you're good. But with tuples, they are not mutable. You cannot change it. Once you've created it, it's in there, it's fixed. With arrays, you can change it. I don't want us to focus on arrays because we're probably not going to use arrays a lot. You rarely use arrays. That's why I just wanted to brush on it and jump off. And the tuples also, they're just comma separated values. We'll talk about how to create all of them at the end of the day. But you can also use tuples to assign multiple variables, which again is something that you will talk about at the end of the day when we get to dictionaries. So one thing to note though is for arrays, since we're not going to talk much about them, this is definitely not very clear. For arrays, when you want to create an array, once you import it, you can import an array. When you want to create it, you need to specify the type of information you want to put in there. If you're creating an array, do you want to put in integer, or do you want to put in string? Do you want to put in float? Do you want to put in double? So you have to do that in the creation. So I'm not going to talk much about that now, but we can practice some of it later on when we come back after our break. So again, the first two data structures, arrays, they are not built in, they are not native. You have to import them for you to use them. They only use homogeneous data types. And if you prefer using scientific methods or numbers, you can use NumPy to import it, or maybe SciPy or Scikit to be able to do that. Now, tuples again, they have different data types. You can mix and match, but know that you cannot change it. So for instance, a tuple, when you might want to use it, is say you want to put in a particular location of a city. In that, you have to create a tuple because the location will take the longitude and the latitude. If you change the order of that, then you're going to have a separate location. So longitude and latitude, where it intersects, will be where the city is. So that would be an example of where you use a tuple because it's fixed. An array, you might want to use an array if you want to save space. Say you want, obviously, when you go to the store to download an app or the app market, you don't want to download an app that is very cumbersome. That's going to take up all the space on your computer or on your cell phone. So when, as a developer, you want to manage the size of your application to make it efficient and more performant, then use an array if you don't really need to use a list. Otherwise, you should definitely use a list. What is a list? A list, again, similar to those tuples. The main difference is a list, unlike a tuple, is mutable. You can change it. Everything else is the same as a tuple. So if you don't need something that's fixed, like the location of a city, then you might want to make sure that you get a list. It's mutable. You can use varying data types. That's totally fine. But a string, what is a string? We started using strings from the onset. A string is also considered a sequence. A string is considered like a list because you have a string of characters. For instance, if you have Python, in this case, Python would be a string of characters with a length of 6, right? The first index, or sorry, the 0 index is P. The first index is Y, and so on and so forth. But also know that you can count indices backwards, okay? For every sequence or set, you can also count the indices backwards. For instance, -1 would represent the last item. -2 would represent the last but one item, and so on and so forth. So strings, again, are very, very powerful in Python. Next week, our next class, we're going to talk only about strings. Why is that? Because strings have many functions that we can use them, and strings are things that you use a lot. If you're going to be looking at text files, or if you're going to be looking at a lot of data, you need all those functions in strings. But remember that a string is a list. So everything that you can do with a list, you can do with a string, except for the part that the strings are not mutable. So if the string says it's Python, you cannot go in and say, change the very first element or the 0 index, change it from P to C. It's going to give you an error and say this is immutable. So what you need to do is create a new string altogether that has that different value in the first index. Does that make sense to everyone? But
so if you have a list of strings, can I say that? No.
Yes.
A sequence of strings. Okay, I don't know what word you use, but I guess you know where I'm coming from.
Yes.
If you have Python, comma, C++, comma, JavaScript, comma, C, comma, can you switch the indexes? Like, if we start with Python, then obviously is 0, as we see here.
Yes.
But can we replace that entire Python with another string, like replacing it with maybe SQL or something?
Definitely. So in that case, you're looking at a string as an element. You're not looking at a string as the entire list. So every element in your list, you can change it. That's why lists are mutable. Does that make sense?
Good. Yeah. So it's element string. Okay, good. I got it. Thank you.
Excellent. Excellent. So yes, in this case, P is the element, but instead of Python, if you had in place of P, you have Python. In place of Y, you had 23. In place of T, you had SQL. In place of H, you had Azure. In place of O, you had AWS. You can always change each one of them, and we'll look at that in the afternoon, or should I say in the second half of today, when we actually start practicing a lot. Sounds good? So that's the main thing with sequences, those 4 different types. Okay, we started with arrays, which are not native with Python, and then we talked about tuples, which are fixed, you cannot change them, and they take varying data types. That's totally fine. And then we talked about lists and strings. Strings are also lists, but strings cannot be changed. Lists can be changed, unlike tuples. Meaning, when I say change in or mutable, I'm talking about the elements or the items within the list. All right, so let's go on and talk about collections. So what are collections? Collections, again, the 2 different types are sets and dictionaries. When we talk about sets, think about union, intersection, and so on and so forth. Those different things that we do with sets that we're already aware of. With sets, we want our items to be unique. So you cannot repeat items within a set. Also, it's unordered. It doesn't really care about the order of the items, but the sets, you can always make changes to them. Okay. So a good use for a set is if you want to find out what are the unique elements in a list, then you can convert your list to a set and then check what the size of the set is. Okay. Also, we have dictionaries. Dictionaries, just like the dictionary in real life, dictionaries have words and descriptions. But in a dictionary of Python, you have keys and values. The keys can be of any data type. The key does not always have to be an integer, because when we think about sequences, the keys were always integers, which are, in other words, known as indices or index. But in this case, your key can be a string, your key can be a double, or it can also be an integer. But when we talk about tuples, again, are immutable. Tuples can be used as key values in your dictionaries, because once you have your key, you don't want to go ahead and change your key. Does that make sense? So again, at the end of the day, as I promised, I hope this table helps you to clarify what the differences are. In here, you're not going to see arrays because, like I said, arrays are not native in Python. So we talked about lists. Lists, the order actually matters because you have those indices. So if you say index 0, it's going to give you the first element. Index 3 is going to give you the fourth element, okay? List, you can change them. It can be mutated. In order for you to create a list, you use square brackets, okay? So you can create an empty list, which you're going to see later on. You can also create a list that has values in there, okay? So an example of a list, as you can see here, this list has values of different data types. It has 5.7, which is a float. It has 4, which is an integer. It has yes. In this case, yes is in quotes, so it's a string. And it has 5.7 again. These two values are repeated, so it's not a set. If you want to change this into a set, we're going to go to the third line. You see that the set, the order doesn't really matter. We can change it. To create a set, we need curly braces. Curly braces. And we can also use the set keyword to create one, because when you use curly braces to create a set and you don't give it a value in there, it's going to automatically think you're creating a dictionary. The dictionary also uses curly braces. The dictionary does not care about the order because it does not use numbers. It uses keys. You can change the values of the dictionary, but you cannot really change the keys, okay? So you can create a dictionary in this format. For instance, you might want to keep track of a particular number for a number of items or number of orders, maybe for each month. Then you can use the name of the month as a key. For June, you had 75 sales. For July, you had 89 sales. And since it's mutable, you can keep adding months and adding months. Or if you made a mistake, instead of 75, it was 25, you can come back and change this to 25. So that's how you create a dictionary or make changes to a dictionary. We are going to practice a lot of this hands-on once we are done with just reviewing the concept. So tuples again, we're not going to talk much about it, but they are ordered. You cannot make changes to tuples. To create a tuple, you need parentheses, or you can use the tuple keyword. All right. As you can see in here, the tuple looks exactly like the list, except you're using parentheses instead of square brackets. And with those parentheses, you cannot make any changes to this tuple. If you need to make changes, you have to create a new one altogether. Does this make sense?
Yeah, you mentioned that tuples cannot be changed.
Yes.
And you also mentioned that you could use that in terms of coordinates of, whatever, a city or something.
Mm-hmm.
But I struggle to know another different application where tuples could be used.
Okay, very good. Another different time you might be able to use tuples. One thing is that I can think on top of my head is social security numbers. If you're saving social security numbers of people, of say candidates or employees or people, you definitely don't want them to come tomorrow and change their social security number, right? So once it's in there, it's fixed and it cannot be changed. Does that help?
Can you add to tuples?
Unfortunately, no. So let's go ahead and let me try opening an example here. Let's see if I can switch over to create a new folder and call that. Nope, that's not where I want to create it. This is where I want to create it. Basics. And I'm coming to you shortly, Fabian. Let's see if we can figure out this one. So let's say tuples. .py. So to create a tuple again, let me make this bigger. We said we needed to use those curly braces, right? Oh, sorry, those brackets. So let's go ahead and say tuple 1 is equal to 1, 2, 3, yes. No. So again, tuples, you can also do them nakedly. If I can use that word in here, let me see if I can go back to our display and see where we had that. So tuples, where is it? It's as simple as a comma separated list of values, okay? So if we do this, this will give us a tuple, okay? If I press enter and check for the type, it's going to print that out for me. So let's print it. and execute that. Before I execute, let me go ahead and clear this stuff from last night. So if we execute this, that tells us that it's of class tuple. Okay. Another way we could have done that is, let's say, use the same thing. Oh, I always do that. Use the wrong key for copying. Let's call this number 2. And I'm going to use parentheses. Let me just go ahead and change the order here. Also go ahead and print that. So let's equal to the type. And this should be tuple1 data type. Oh. That's one. That looks good. So let's execute that. It tells us both of them are tuples. Now, if we wanted to go ahead and make changes, which is something we haven't talked about yet, if we want to identify the first item in tuple1, what we need to do is we'll type in tuple1, and then we use that index. Okay. Is everybody okay with me? So the first index is 0, and then we can also do the same for tuple2. I'll call that tuple2. Let's print it out and see what we got. So the first item for tuple1 is 1. That's true right there. The first item for tuple2 is yes. Now that's just accessing it, getting access to that value. If we want to change it, it's definitely going to give us an error. So let me clear this out. Oops, I can't spell. And go ahead and try changing it. So to change it, all I needed to do is tuple1 should now, at that first item, I'm going to assign a particular value and say new value. So that's how I'll assign new value into that space for tuple1. I want it to go in here. If I execute that, it gives me a type error. The tuple object does not support item assignment, so I cannot assign that item. Does that make sense?
Yeah, if we 1, 2, 3, 4, 5. If we change the index to 5.
Okay, so if we change the index to 5 in terms of adding it.
Yes.
So let's go ahead and execute that. It does not accept index assignment. So when you say mutating, that includes adding. So you cannot add or change any value. That size is always going to be the same. If we need to add it, that's when we have to use conversion. We have to figure out a way to change this tuple into a list. Okay.
Okay. And then maybe change it back afterward.
Yes. And then maybe create a new, let's say, instead of using tuple1, we'll have to call it something else, maybe tuple1 list. So something like tuple1 list will now be equal to list. And then just go ahead and put in the tuple in there. Now you've converted it to a list. And if I comment this out and check for the data type for tuple1 list, after assigning that, that's the wrong one. Copy this. Tuple1 list data type. And I can do that. Execute this. Let's clear this out again. You can see now that tuple1 list data type is a list. Make sense?
Yeah, cool. Thank you.
Excellent. Fabian, question.
Yeah, I had a question about the dictionary.
Yes.
You said we can dictionary is like a key value assignment.
Yes.
But the key cannot be changed. However, the values can be changed. And I saw that you were using like column to separate the values. I was wondering whether on the values side, you can make it a list of values.
Wow. These guys are giving me a hard time today. Very good question. Short answer is yes. long answer. Let me go ahead and actually let's just use the same one. I don't need to create a new one. So how do we create a dictionary? We can go ahead and create an empty dictionary by saying, let's just say dictionary1 is equal to that. So that creates a dictionary. If you try creating a set that way, it's going to change it to a dictionary. After doing that, let's go ahead and say, check the data type. That'll be a good thing. Let's check the data type for that. And execute our code again. Now it tells us dictionary1 is a dictionary, right? Now we want to go ahead and assign values to it. So we can go ahead and say dictionary1 and give it a particular assignment. Let's say give it a key. In this case, I think that's something that we should do later on this afternoon. And let's say tuple1, assign it a value, 1. Expression cannot be assigned, target, blah, 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 blah. Sorry. I don't know why I always do that. So again, you want to use square brackets. Okay. Just like we use square brackets in this one that I commented. Okay. So square brackets is used to get a particular position. In this case, the position is not necessarily a number. It could be any data type. Okay. So here I'm saying tuple1 should be assigned tuple1. So if I do that and then print the dictionary and go ahead and see what it looks like. Let's execute that. Let's clear this out first. Oopsie. I think that's today. Clear that out. You can see now that tuple1 list is a list, as we can see here. And then we printed dictionary1 data type. The data type is a dictionary. We went ahead and said our key should be tuple1 and the value should be the value of tuple1. So here we have tuple1 as a key. The value is that tuple. So you can make it as complicated as you want. In this case, it's a tuple. We can go ahead and also add a list in there, right? So if we went ahead and say dictionary1 and let's give it 1. Let the key be 1 in this case. And the value should be 1 list. So now I've added 2 values. Let me go ahead and comment those. We're adding key value pairs to the dictionary, and then we print it out. So let's execute that. Should probably clear it so we have more space. If we execute it, everything else from the beginning is going to print out. Now we have a dictionary. The first key is tuple1. That is the value. The second key is 1. That is the value. So you can get as complicated as you want, or you can keep it just simple and just have player 1, the value, player 2, the value. Make sense?
Makes sense. That answers my question perfectly well. Yeah.
Any other questions? So I have a question for you guys. Is anybody here familiar with, let me switch back to that. Is anybody here familiar with JSON?
Yes.
I heard of it last week.
Excellent. Tell me, what do you know about JSON?
I use it for cloud formation templates, both YAML and JSON.
There you go.
Yeah.
So JSON is pretty much a dictionary. That's what we're just looking at here. Okay. So what we have done here is an example of JSON. Let me say JSON example and see if we can. So yep, there we are. So in here, this is a dictionary. The key of that dictionary is glossary. Within that dictionary, you have a nested dictionary. In this nested dictionary, you have another key that is title. The value is example glossary. Another one that is close division, and so on and so forth. So once we exercise, we do a few more exercises of this of our code, we'll be able to look at a lot of examples, and you'll be able to understand clearly where we come from when we talk about JSON. So It's very powerful. We'll get to learn a lot about it. Like I said, you also get to use it quite a bit. Oops, I'm going somewhere else. I need to put this in a different location, but it's not being nice to me. All right, so what other questions do you have? Questions, comments, concerns? No questions. So we're almost at the top of the hour. Okay, we've been able to go through everything so far that I've intended to do this morning. And when we come back after collections, now it's a break time. It's always better for us to get something flat rather than nested, and parse is always better than dense. So I'll give you 10 minutes break. When we come back from our break, we're going to practice. We're going to create lists. Good thing we've already done some tuple stuff. We're going to create lists. We're going to use lists. We're going to manipulate with lists. And then we'll also do the same thing with dictionaries. I know we prematurely jumped into dictionaries, but we'll do a little bit of introduction again into dictionaries, manipulate with them a little bit. And if time permits, I'll be able to introduce to you matplotlib. Is anybody familiar with matplotlib?
No, I'm not.
Okay, so it's a visualization library. It's a plotting library for Python programming language, right? So
yeah, I'm looking forward to that. I've heard of it. I have no clue.
Yeah, so what my intention is, since we're going to be talking about lists and dictionaries, we can probably see how we can use lists to maybe hold data and then plot it using another library that will just import and then execute it. Now that we understand how lists are, maybe you can use lists to hold the information of your orders or your months, and then hold information for your sales, and then plot a bar chart. Or you can also use it to hold a bunch of other different types of information and have some kind of visualization, maybe even a line chart, depending on what type of visualization you're looking at. Sounds good?
Yeah, I'm looking forward to that. I use a lot of Power BI, so
yes,
I want to see how
definitely. So yeah, now you get to see the difference, advantage and disadvantage of Python and Power BI. You see how flexible you can make your things using Python, but Power BI, you're only, limited to using the GUI, the graphical user interface, to make your changes. Excellent. All right.